So piecewise functions is where we use different formulas over different domains to make an overall function. So the key is that it's made up of different pieces. So an example of a piecewise function looks like this. So we have our function. There's kind of three possibilities for our function. And to know which part of the function we're using, we look at the domain. So the idea being that if x is less than or equal to -2, then that x squared is our function. If we're between -2 and 5, then 2x minus 4 is our function. And if x is over 5, then our function output is -6. So just finding values for this, what we would do is look at our input, because that's going to be our x value. So for this first example here, it's saying x is 0. So what we want to do is figure out which domain does that fit. And x equals 0 fits between -2 and +5. So that means my function is the 2x minus 4. So I would use that function as we usually use it. So 2 times our input minus 4, where our input is 0. And that would simplify to -4. So then for our next example, where x is now -6, we do the same thing again. We look for which domain does x equals -6 fall into. And -6 is going to be less than or equal to -2. So, because that fits in that domain, our function is x squared. So we're taking our input and squaring it, where our input is -6. And -6 squared is +36. If x is -2, now what we can see is that -2 is kind of on the barrier of our domains. It's separating these two functions. So with that, we need to figure out which one actually contains -2. So where we have this -2 is less than x is less than or equal to 5, what we can see is that x has to be larger than -2, but it's not equal to. Where we have equality is with the x squared function. So to have x equals -2, that's actually in that first function of x squared. So when we have x equals -2, we're plugging into x squared, which would give us +4. So keep in mind that these are functions, so for each of these inputs there can only be one output. So at no point would you be plugging into both of the equations. You will only ever use one when you're given an x value. Alright, x equals +2. That's going to fit this middle case here. +2 is between -2 and 5. So we're going to plug into the 2x minus 4. So we'll take 2 times our input of 2 minus 4, which is 4 minus 4. So that's going to simplify to 0. If x is +8, that's going to fit this more than 5 scenario. And in that case, our output is just -6. So I don't have any calculation to do. That's just -6. And f of 5, so if x is equal to 5, again, that 5 is on the edge of two functions. We need to see where do we have an actual equality with 5, and that's going to be the middle function. We can have x equals 5 for that 2x minus 4, so we're taking 2 times our input of 5 and subtracting 4. So 10 minus 4, which is 6. So in terms of evaluating, that's how we use our piecewise function. It's just a matter of figuring out with your value of x, which domain does that fit, and that tells you which function to use. Now our next video is going to be all about graphing with these piecewise functions, but let's get a little preview based on what we're using here. So let's say I want to graph the quadratic function, but only over x is less than or equal to -2. So we practiced our basic functions. So if I wanted to picture our quadratic function, and I'm just graphing kind of the whole thing here, I can grab my key points there, and then I can see my overall quadratic function. Now that would be if my domain was all real numbers, plugging absolutely anything in. But what I want to do is only have this graph working where x is less than or equal to -2. So when I'm at -2, we'll have that coordinate, which is the +4, and then we'll have our graph for every value of x that's less than that -2 as well. So what I just drew in black there is our function, and then what I had in blue for showing our whole function, I'm going to erase that. So that little snippet of the graph, that accurately graphs x squared over x is less than or equal to -2. So that's where we're ending up with pieces of these functions, so that we just have this little piece of our quadratic. And then 2x minus 4, which is linear, so I have my y-intercept of -4, and then a slope of 2. So I could graph my full line here. However, they're giving me this domain of I just want to see this graph from -2, but not including -2. So what I'm going to do is go to -2 and draw an open circle where the line lands. And then I'm graphing it until +5. So x equals 5, 1, 2, 3, 4, 5. And I'll have a solid circle there because we'll have equals. And then we just connect the dots. But I don't want to graph the line outside of those values. We're only having these values come up between -2 and +5. Now, with these cases of -2 and not including it, sometimes students jump to like starting the graph at -1, but what you want is this idea of being infinitely close to x equals -2. It's like we just want to stop right here, but we want everything up until like x equals -1.9999999 as much as we can. So with that, you can use these values at the endpoints. It's just if you don't have equality, use the open circle. If it is equals, then you can use a solid circle. All right, and the last piece here is to draw f of x equals -6. So this is just going to be the constant function, which is just a horizontal line. And we're going to graph this for x is more than 5. So what I'm going to do is go to x equals 5, and where I'd be graphing a point there, but we would use an open circle. And then I'm just going to draw my line off to infinity, so it'll be defined for all those, and then I just erase anything else that's outside of those bounds. So this is how we can graph parts of a function over a specific domain. So now let's see what happens when I put all these together. So the x squared from -2 off to -infinity. So I have my x squared piece. We have our linear function from -2 but not including -2 to +5, which I believe was up at 6. Let me make sure I have that right. -2, -8, +5, +6. Perfect. So there's our line between those two values. And then from -6, but not including, off to infinity. This right here is the graph of our piecewise function. So when we start graphing these, we'll be grabbing the pieces, all these little domains. But what can really help is to think of it in these segments like we separated here. You don't have to do this every time, and the more practice you get with these, they'll be faster. But starting off with these, think about the pieces, because trying to graph it all at once can be very difficult. And while we get practice with these, it's better to break it up into the pieces and then graphing it all together. Now, the most common mistake with these is to draw a line longer than you should, like continuing our quadratic by accident, or continuing our line by accident, or just drawing all three functions. But keep in mind that this is a piecewise function. So this should all graph one function, which means it has to pass that vertical line test. So drawing vertical lines should only ever be passing through our graph once, at most once. So in every location that should hold true, and if I could just have students check this every time, it would make life so much easier, because that's the quickest way to figure out whether or not something's wrong with your graph. Check that vertical line test, and if it fails, then something went wrong with the graphing. So just be sure to use that as a backup for checking your answers.